Okay, we're continuing with the statistics textbook. We just completed part 1, which was on design of experiments. Now we're starting part 2, descriptive statistics. In this video, we're going to be starting chapter 3, which is on the histogram. We're going to go through section 1, introduction to the histogram. All right, so it starts off by introducing us to a case study. In the U.S., how are incomes distributed? How much worse off are minority groups? Some information is provided by governmental statistics obtained from the current population survey. And so this book was originally published in the 1970s. So I'm assuming that they're talking about the current population survey. We're talking about a survey that was conducted in 1973. So this was current at the time. Each month, interviewers talk to a representative cross-section of about 50,000 American families. In March, these families are asked to report their incomes for the previous year. We are going to look at the results for 1973. These data have to be summarized. Nobody wants to look at 50,000 numbers. To summarize data, statisticians often use a graph called a histogram. Okay, so to get an idea of income distribution in the United States, they do a survey with I'm assuming a completely random sample of 50,000 American families. So these 50,000 families, I'm assuming it's well randomized in some way. They ask the adults in these families for their income, their yearly income for their most recent year. And so you get 50,000 data points, right? 50,000 numbers. One way to summarize these numbers, right? Because you can't just stare at an Excel sheet of these numbers. What use is that? So one way to present or summarize these numbers is with a graph called a histogram. So if we come here, this is a histogram of that data, the annual incomes of the 50,000 families. So what do we notice about this? What are some first things that we can notice about this diagram? Well, first of all, it doesn't have a vertical scale, okay? Histograms don't have to have a vertical scale. Many of them do, and we'll talk about why, but they don't have to have a vertical scale. There's a horizontal axis, which represents the income in thousands of dollars. So this is $5,000 a year, $15,000 a year. It goes from zero to $50,000 a year. We can see that we've got these array of blocks of different sizes. Different sizes in terms of the areas of the blocks are different, but also the widths of the blocks are different. And so that's another feature of a histogram. A general histogram does not have to have equal width blocks. You might be familiar with histograms that have equal width blocks, but that's not necessary. You don't have to have that. This section explains how to read histograms. First of all, there is no vertical scale, unlike most other graphs. A histogram does not need a vertical scale. Now, again, so a vertical scale is not necessary, but we're going to learn how it's very helpful to have a vertical scale. That's why a lot of histograms you see do have a vertical scale. Now, look at the horizontal scale. This shows income in thousands of dollars. The graph itself is just a set of blocks. The bottom edge of the first block covers the range from $0 to $1,000. The bottom edge of the second goes from $1,000 to $2,000. And so on until the last block, which covers the range from $25,000 to $50,000, right? So each block has a range, right? This goes from 0 to 1,000. This goes from 1,000 to 2,000. This goes from 15,000 to 25,000, right? Each block has a range, and as we talked about, that range, the range of each block doesn't have to be equal. These ranges are called class intervals, okay? So that the class interval is not the width of the block, it's the range. So the range, so like, in other words, the range of this block is 0 to 1,000. The range of this block is 1,000 to 2,000. So the widths of the block are equal, but their class intervals are not equal, because the class interval for this block is 0 to 1,000, and for this block it's 1,000 to 2,000. You see? The graph is drawn so the area of a block is proportional to the number of families with incomes in the corresponding class interval. So that's important. In a histogram, the areas of blocks are proportional to the number of data points in that interval. the area of the block is proportional to that. So in this case, the number of families with incomes in the corresponding class interval. To see how the blocks work, look more closely at figure 1. About what percentage of the families earned between $10,000 and $15,000? So, okay, what percentage of families earned between $10,000 and $15,000? Well, when you have a histogram, the area of all of the blocks combined, you can think about that represents all of the data points in the entire data set. Now, you might be wondering, well, so no families made more than $50,000 a year? Well, first of all, remember this is 1973, so don't, take inflation into account. But then if you come here, it says the horizontal axis in figure 1 stops at $50,000. What about families earning more than that? The histogram simply ignores them. In 1973, only 1% of American families had incomes above that level. Most are represented in the figure. So the entire area of a histogram is either 100% or close to 100% of all of the data. So since the areas of the blocks are proportional to the number of data points within that interval, then the percent of data points within an interval is equivalent to what percent is the area of that block in that interval compared to the total area of the histogram. You see how that works? So it says the block over this interval from $10,000 to $15,000 amounts to something like 1/4 of the total area. So about 1/4 or 25% of the families had incomes in that range. You see, so this area, it's saying, is about 1/4 of this total area, which means that about 25% of the data points of the 50,000 American families surveyed fell in this income range, $10,000 to $15,000. Take another example. Were there more families with incomes between $10,000 and $15,000 or with incomes between $15,000 and $25,000? Okay, so we're comparing this block to this block. And it looks like this block is taller, but this block is a bit wider. So these look to be about the same areas individually. So this would be 20. So if the incomes between 15 and 25, we could say, is about 25% of the total of all the families. And this is about 25%. And that's what it says here. The block over the first interval is taller, but the block over the second interval is wider. The areas of the two blocks are about the same. So the percentage of families earning $10,000 to $15,000 is about the same as the percentage earning $15,000 to $25,000. Okay. For a last example, take the percentage of families with incomes under $7,000. Is this closest to 10%, 25%, or 50%? So earning under $7,000. So this entire area here. Well, I wouldn't say this is 50%. Maybe all of this is closer to 50%. This looks more in the 30% range, 30% of all of this area. So between these three, I would choose 25%. By I, the area under the histogram between $0 and $7,000 is about 1/4 of the total area. So the percentage is closest to 25%. Okay. In a histogram, the areas of the blocks represent percentages. So remember that for any histogram you ever see, in a histogram, the areas of the blocks represent percentages. Okay. So a histogram doesn't have to have a vertical scale. The widths of the class intervals don't have to be equal. Don't have to be. Again, these just aren't requirements. But in a lot of cases, it's good practice, or it's convenient to do that to do this. Okay, and the areas of the blocks represent percentages. The reason being is because the areas of the blocks are proportional to the number of data points within that interval. So the first 2 points, the class interval widths and the vertical scale, those aren't requirements. But the areas of the blocks representing percentages, because the areas of the blocks are proportional to the number of data points within that interval, that is a requirement of a histogram. Okay, so now we're gonna work a few example problems. Figure 2 shows the same histogram as Figure 1, but with a vertical scale supplied. And so here's Figure 2, but now it has a vertical scale. This vertical scale is going to help us to solve these problems. So again, a vertical scale is useful, but it's not necessary. You don't have to have one with a histogram. And we'll talk about the design of vertical scales, how you make vertical scales for histograms in the next section. But for now, we're just going to use this as a tool to solve these problems. About 1% of the families in Figure 2 had incomes between $0 and $1,000. Estimate the percentage who had incomes in all of these ranges. All right, so between $0 and $1,000, about 1% of the families were in this interval, okay? Now, we know that the area, for any histogram, the area of a block represents the percentage of data points in that block. And so if the percentage of data points in this block is 1%, and we also see that if we take the area of the block using the vertical and horizontal scale, it's 1 times 1, right? 1 in thousands of dollars, because this is just 1, because the horizontal axis is in thousands of dollars. It goes from 0 to 50. So we can see that for any block, we just need to calculate its area using this vertical and horizontal scale, and that's going to be the percentage of data points in that block. Okay, so between 1,000 and 2,000, we've got 2 times 1, so 2%. Between 2,000 and 3,000, we've got 1 times 3. Between 3,000 and 4,000, you've got 1 times 4. Right? The height is 4. Between 4,000 and 5,000, that's this block. The height is 5, the width is 1. And between 7,000 and 10,000, that's 5, so 7 to 10, the width is 3, the height is 5. In Figure 2, were there more families earning between 10,000 and 11,000 or between 15,000 and 16,000? So between 10,000 and 11,000 or between 15,000 and 16,000. The widths of those two blocks are the same, but this one has a larger height. So between 10,000 and 11,000 for sure. The histogram below shows the distribution of final scores in a certain class. Which block represents the people who scored between 60 and 80? This block, Block B. 10% scored between 20 and 40. About what percentage scored between 40 and 60? So 10% scored between 20 and 40. If we look here, between 20 and 40, if we take the area of this block, it's 20. This width is 20 times 1, so it's 20, which represents 10%. So what we need to do is to get what percent score between 40 and 60, what's the area of this block? That's 20 times 2, that's 40. So what is 40? How much bigger is Block C than Block D? It's 40 divided by 20. It's twice as big. So if this represents 10%, then this is going to represent 20%. You see? Because the areas of the blocks are proportional to the percent of data points in that interval. So you can take the ratios of blocks to see how much more of a percentage of data points are in one block relative to another. About what percentage scored over 60? So over 60. What is the area of these two blocks combined compared to the area of the first block we know is 10%, or the second block since we know is 20%. So 60 to 100, that's 40. Well, okay, no, 60 to 80, that's 20 times 4, 80. And then 80 to 100, that's so 20 times 3, 60. 80 plus 60 is 140. What is 140 divided by 20? That's 70. So these two blocks are 70 times as much area as Block D. So the Block D is 10%. So this is, or 7, sorry, 7. 7 times as big. So take 7 times this, not 70 times this. The area of these two blocks is 7 times as big as the area of this block. So take 10% times 7, and you get 70%. Below are sketches of histograms for test scores in 3 different classes. The scores range from 0 to 100. A passing score was 50. For each class was the percent who passed about 50%, well over 50%, or well under 50%. Okay, so these are 3 different classes. This one was the percent that passed, which means got a score of 50 or above, well over, well under, or about 50%. Well, to see the percentage of data points in any interval, you look at the areas. So here's 50, right? Well, this area is bigger than this area. It's well bigger. It's a good bit bigger. So this is over, right? Okay. What about this? Well, the majority, that there's a big area here and a smaller area here, and then pretty much no area here. So under, most didn't pass. All right. Here, it's like evenly distributed about 50, the areas. So about 50. See how that works? One class in exercise 4 had 2 quite distinct groups of students, with one group doing rather poorly in the test and the other group doing very well. Which class was it? This one, right? You got like pretty much no students made between a 50 and a 90. A big chunk, it was just a big chunk failed, and a big chunk did really well. That's exactly what they describe here. One group doing rather poorly on the test and the other group doing very well, right? You have to see where's the area distributed in the histogram. That tells you where the data points are. In class B of exercise 4, were there more people with scores in the range 40 to 50 or 90 to 100? So 40 to 50, that's about right here. Well, 90 to 100 and 40 to 50, that's the same width, but this is higher, so 90 to 100. Right? The same exact width. 40 to 50 and 90 to 100 is the same width, horizontal width, but this is taller. Okay, an investigator collects data on hourly wage rates for 3 groups of people. Those in Group B earn about twice as much as those in Group A. Those in Group C earn about $10 an hour more than those in Group A. Which histogram belongs to which group? So the way you want to look at this is, it's saying, okay, an investigator collects data on hourly wage rates for 3 groups of people. So it's these 3 data sets with their 3 separate histograms for these 3 different groups of people. Those in Group B earn about twice as much as those in Group A. So, well, which data point are they talking about, right? Like those in Group B earn about twice as much as those in Group A. What does that mean? Because Group B is a bunch of data points. Group A is a bunch of data points. You can think about this as like the mean value. So they're saying that if you take like the mean value of Group B, that's going to be about twice as much as the mean value of Group A. And then the mean value of Group C is about $10 more than the mean value of Group A. So what's the mean value? That's going to be right in the center of the area distribution, right? So here, this will be about, the center of this area distribution would be about right there, I would say. Maybe a little bit more to the right, to the left, I mean. And then here, right there, and then here, about right there. Okay, so this looks to be about, so this is about 12. So this is about 12. This is about another halfway, so maybe about 20-ish. Okay, this is, so halfway is about 12. This is maybe about 8-ish. And then this, so, okay, this is halfway is 12. And maybe this is 18. Okay, so those in Group B earn about twice as much as those in Group A, and those in Group C earn about $10 an hour more than those in Group A. So this is going to be Group A for sure. Now, Group B, twice as much as those in Group A, so 8 times 2 is 16, or maybe we can say 9 times 2 is 18. So maybe this is B, but then Group C earns about $10 an hour more than those in Group A. So this is about $10. So to me, it's hard to decide. I guess so. Okay, you'd put C here, and then this would be twice as much. So this would be 16, but if it was 9, it'd be I mean, it's too close to the same, but so BAC. But you get the idea. I mean, you have to do a precise analysis of this and like do the scale. So really draw this to scale and get the numbers. But yeah, that's the idea. So, okay, we're not going to do problem 8. So that's the introduction to the histogram. In the next section, we're going to talk about how you draw a histogram.